You guys remember that. And then, can someone read this example for me?
The time it takes a driver to react to the brake lights on a decelerating vehicle is critical in helping to avoid rear-end collisions. Reaction time to a brake signal has a normal distribution with a mean of 1.25 seconds and a standard deviation of 0.46 seconds. What is the probability that reaction time is between 0.79 seconds and 2.17 seconds?
All right, so normal distribution with a mean of 1.25 seconds and a standard deviation of 0.46. What's the probability that reaction time is between 0.79 and 2.17? Does anyone think that they can do this? Come up here and do this for the class. Anyone? You got it.
I got this.
Yeah.
Right, so we just figure out like where the standard deviation is. So I'm assuming that right here is probably mu minus 1 standard deviation, 7.9. So that means that in this area there's a 34% probability or whatever. And then mu plus another standard deviation is, anyone have a calculator?
1.71.
7.1, and then the other standard deviation, you want to get that?
2.17.
2.17, and is that what we're going for? Yes. Yeah. So that means that in between this area, there's a 68%, and then here is like 13, I think. 13.5.
Yeah.
So we just add that up, and that's 70, 82, 81.5, maybe?
81.5. Yep, perfect. So the probability that the reaction time is between 79 and 2.17 is 81.5%. Does everyone understand that? Yeah? Okay, good job. So standardizing, the mean is 0 on just a standard normal curve. We consider mean 0, and each standard deviation is just 1. And then you were perfect with the 98 or 68, 99, 95, 99.7 rule. And then what is the percentage of values between 0 and 1.5? You can't tell, yeah. You can't do it because between 1 and 2, we know, between 1 and 2, we know 13.5% of the data is between that, but we don't know like where it is between that specifically, so you can't do it. Does that make sense to everyone? Okay, perfect. So, if we have a normally distributed curve with mean mu and standard deviation sigma, then we can use that equation, which is on your formula sheet at the very top. And that's finding z-scores. So can anyone tell me what a z-score is?
It's the standard deviation of the number of...
Yeah, how many standard deviations we are away from the mean. Yeah, that's perfect. And this is on a lot of things, so remember this. How many standard deviations we are away from the mean. Okay, can someone read this one for me? Anyone?
The weight distribution of parcels sent through a parcel service is approximately normal, with a mean of 12 pounds and the standard deviation of 3.5 pounds. How many standard deviations away from the mean is a package weighing 16 pounds? Or what is the z-score?
Okay, so can anyone come up and do this? Find the z-score.
Okay. So, minus 12, so I'll write the formula down. For sigma look like again?
Medium.
Medium, like,
Funny M, yeah.
there we go, okay. So 16 is what we have, and then the mean is 12. That's over at 3.5. So 4 over 3.5, so 1 and an 8, I think. Not a calculator.
It's like
It's-
1.1.
Yeah, 1.14.
Okay.
Perfect, that's it. Good job. Did everyone understand that? Yeah. Okay. So now we're gonna move on to finding areas underneath the curve. So if I had a graph that was normally distributed, and this is my mu, but I want to find the area right here. What do I do? Like, is this just the z-score? Like, we just find the z-score, find the probability. Here, let's pull this up. So, area to the left is just the probabilities on your sheet. But on your sheet, they only give the areas to the left. So if you're trying to find the area to the right, over here, then you have to do 1 minus the probability that you find. And then areas between, you take one probability minus the other probability. So we're going to practice these real quick. You take the SAT and score 1,100, 1,100. The mean score for the SAT is 1026, and the standard deviation is 209. How well did you score on the test compared to the average test taker? Does someone want to come up and do this for me? Anyone? Do you want to do it?
We'll help you if you're not
Do you
sure.
want to help? Okay. So the first step always is what my professor told me. Professor Reese, he emphasizes drawing it out because it's really helpful to see it visually. So normal distribution. What's the mean?
102.
What's the standard deviation? And you got 1,100. So okay, so what's our next step?
Just find the z-score.
Find the z-score.
Here's the formula.
So what's x?
1100.
1100.
Minus
1026.
over
200.
someone have that?
Yeah, it's 0.354.
Okay, so that's our z-score. What do we do after that? Okay, go to our, let's see.
Where can you guys find your formula sheet and this table?
Syllabus.
On the syllabus, and where else? The content tab, right. It's on Learning Suite. Oh, is it raining?
It was intramural scheduled pickups today.
Oh.
So do you just have to look at all this and find it?
So yeah, so you go to your chart and then you find 0.35. So on here, we found 0.3. This is 0, 1, 2, 3, 4, 5. So our probability is 0.6368. And if we go back to our problem, what is 0.368 telling us? Dealing with this.
You like you
What-
did better than 63% or 62.7%.
Yeah, exactly. Perfect. Okay, we're gonna do. someone read this for me?
In the United States, the average IQ is 100 with a standard deviation of 15. What percentage of the population would you expect to have an IQ score above 100?
Okay, so what should we do first?
C score.
Draw it out.
Draw it out. Perfect. Draw it out. So the average IQ is 100. Standard deviation of 15. So what's our x?
120.
20. And then our mu is 100 over 15, our standard deviation.
Oh, 0.33.
1.33. So then what do we do? Go to our chart. And we find 1.3 and go over, so 0.9082.
So that's our answer, right?
Is that our answer?
No.
No, so we're right here. 120. We're trying to find this area. Do you think that's 90% of the data? No. So that's why you draw it out, so you can tell. So what do we do? 9082. Do 1 minus that. And it equals, sorry.
0918.
0.0918? Yeah, perfect. Good job. Does that make sense to everyone?
So the question again is how many people scored better than that, and the answer would be 9%?
Yeah.
9.1%, okay.
Yep. Perfect. And then last one.